Hey everybody, today we're talking about assignment 8-1 scale factors. So this is our second one for the week. We're building on what we did yesterday with scale drawings. So as we look at scale factors, this is just a little bit different, but it's kind of built off the same thing. So scale factors, when we look at this, is a scale written as a ratio without units in simplest form is called a scale factor. So suppose a scale model has a scale of 1 inch equals 2 feet. Now again, inch and feet, that's two different kinds of measurements. So 1 inch equals 2 feet. So 1 inch equals 2 feet, which means 1 inch over 2 feet, right? And that leads to 2 feet is actually equal to what? 24 inches, right? So we move on and we get this 1 inch over 24 inches. So we get a scale of 1 to 24. Okay, so hopefully you can see that kind of here. So we get that 1 to 24. So we're talking inches on both of those numbers. So that's really an accurate scale or an accurate ratio, is because both of our units of measure are the same. We're not going from inches to feet, it's inches to inches. Okay, so 1 unit on the model represents an actual distance of 24 units. So the model is 1 to 24th the size of an actual object. Okay, so when we give a actual scale, so if I have a model car that I'm building and it's 1 to the 64th size of my regular car sitting in my driveway, we know that is, for every 1 inch of the actual car, it's, or for every inch on my model car, it's 64 inches on the real car that's sitting in my driveway. Okay, so we need to understand that when we make our units of measure the same. So if we look at this first kind of slide that has stuff on it, so if we kind of find the scale factor of a model sailboat, if the scale is 1 inch to 6 feet, so we already have our 1 inch to 6 feet right there. Okay, so we have 6 feet on the bottom. Okay, so if we have 1 foot equals what? 12 inches, right? Does that make sense? Okay, so if we want to find out, okay, how many inches, we need to figure out how many inches 6 feet is. So 1 foot is 12 inches. So we need to take our 6 feet and times it by 12 inches, right? So we have 6 feet times 12 inches, which equals 72. Okay, so that's going to be 72 inches, right? So we have our 1 inch, and we have our 72 inches. So we really end up with this, okay, 1 inch over 72 inches. So that means our scale factor is equal to 1 over 72. Okay, so that's our scale factor. So that's what we're talking about. 1 inch is equal to 72 inches. Okay, so instead of 6 feet, we're using 72 inches. Okay, so that kind of makes it accurate. It makes our unit of measure the same, which in some respects is going to make some things easier. So let's find the scale factor of a dragonfly if the scale is 1 centimeter equals 15 millimeters. Okay, so we have 1 centimeter over 15 millimeters. Okay, so hopefully we understand that. So 1 centimeter is equal to 10 millimeters, which means 15 divided by 10 is going to equal 1.5 centimeters. Okay, hopefully that makes sense. So that ends up giving us 1 centimeter over 1.5 centimeters. Okay, so our units of measure are the same. So that makes our scale factor is going to be equal to 1 over 1.5. Okay, so that's our scale factor right there. Okay, so we need to make sure that we can change inches to feet, millimeters to centimeters, those sorts of things. So that's really important for us to be able to do that. So hopefully some of you science kids that had me in science where we covered metric can understand the centimeters and millimeter things a little bit easier. So let's go ahead and go to the next slide. So this is just kind of a slide that just kind of something that we need to always remember to hopefully make it common sense that we remember. So if a shape becomes twice as big, the scale factor would be 2. Okay, so if we had 1 and 1, and that was 2 and 2, obviously we're going from 1 to 2, 2 over 1, that would be 2. Okay, so we're talking twice as big, so that means we're doubling it. So it would go from 1 to 2. So if a shape shrinks to half its size, the scale factor is half. So let's take a look. So if we did, anything, okay, so if we take this and we cut it in half, we make it smaller, and it's gotten smaller, that means our scale factor is going to be half. Okay, so if this is 2, this is 4, we made this 1 and 2, it's half the size. Okay, so hopefully that makes sense. In a sense that we can go twice as big, scale factor would be 2, we go half as small, our scale factor is half. So hopefully that makes sense. So let's see that in practice on our next slide. So how many times bigger is the blue shape? So what did we get? So the blue triangle is bigger. Okay, so what we need to do is we need to make sure that we're comparing our sizes. So let's take these two sides, okay, 10 over 5, okay, which is going to be equal to 2. Okay, then we take 8 over 4, and that's going to be equal to 2. Okay, so our scale factor is going to be equal to 2. Okay, so how many times bigger is the blue shape than the red shape? It's twice as big because our scale factor is 2. Okay, so that's something for us to understand. So the triangle got bigger, so it's an enlargement, which means the scale factor is greater than 1. Anytime we're going from a smaller shape to a bigger shape, our scale factor is going to be 1 or greater. Okay, so hopefully that makes sense. So if we're going from a smaller shape to a larger shape, that means our scale factor is going to be 1 or larger. So always remember that when you look at your answer and ask yourself, does it make sense? We were working on that this year, looking at our answers and say, does it make sense? So that's one thing to remember. When we look at this, take a look at how the transformation, what is the amount of reduction? So one thing we always want to do is we always want to take the pattern of you take the new figure over the original figure. Okay, then divide or reduce. So we have 2 over 6, and that's represented right there. Okay, and then we have 3 over 9, so that's represented right there. So 2 over 6, we reduce that to 1/3. 3 over 9 is going to reduce to 1/3. Okay, so what's our scale factor going to be equal to? Our scale factor is going to be 1/3. Okay, so there's our scale factor right there. So if we look at this, okay, so make sure that we're taking notice of this, okay, that we always take the new figure over the old one. And then if we look at this down here at the bottom, it says the rectangle got smaller, so it's a reduction, which means the scale factor is going to be less than 1. So if we go from a larger we go from a larger shape to a smaller shape, then our scale factor is going to be less than 1. Okay, so hopefully that's something you guys can remember. So if you come up with a fraction, when you go from a larger shape to a smaller shape, that a fraction is perfectly okay. That's what you're going to come up with, because it's going to be a number smaller than 1. Okay, going from smaller to bigger, you're going to have a scale factor of 1 or larger. If you're going from bigger to smaller, we're going to have a scale factor of 1 or smaller. Okay, so always keep that in mind. So what is the scale factor of a rectangle that was enlarged to be given the dimensions? Okay, so our original rectangle, I say go ahead and draw it out. So let's say it's 5 by 7. Our new rectangle can be a little bit bigger. Okay, that's going to be 15 by 21. Okay, so those are our measurements. So we're going to have 15 over 5. Okay, that's the 1. And then we're going to have 21 over 7. Okay, so 15 over 5, so that's 15 divided by 5 is going to be 3. 21 divided by 7 is going to be 3. So when we're going from a smaller shape to a bigger shape, our scale factor is going to be larger than 1. So right here, our scale factor is going to be equal to 3. Okay? So there's our answer. So hopefully that makes sense for you as you go forward. So make sure you keep in mind when your scale factor should be 1 or greater, or when your scale factor should be less than 1. Okay? So let's go on, and we're going to see this. We're going to use a graph for this, so don't panic on me. So we want to create a figure B with a scale factor of 3. Okay, so this is not going to be difficult. Let's just follow along. So find the length of each side and then multiply by 3 to get the length of sides of the new figure. So the scale factor is greater than 1, so it means enlarging the figure. So when we're going from smaller to bigger, it's going to be greater than 1, so we want a factor of 3, so that means our new shape should be bigger than A. So figure B is going to be bigger than A. So let's look at what we are. So we got 1, 2, 3. So we know that this side is going to be 3. We have 1, 2, so we know this side is 2. Okay, so hopefully that makes sense. So we have 3 and 2. So we're going to multiply these both by 3 because we have a scale factor of 3. So 3 times 3 is going to be 9. And 2 times 3 is going to be 6. Okay, so this is going to be our new size of our new shape. So if we look at our new shape, let's start right here. Okay, so we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're going to go down to here, and then we're going to go 6 to the right. So 1, 2, 3, 4, 5, 6. Okay, so then if we draw that, okay, so this is figure B. Okay, and that's what it should look like. This is 9, this side should be 9, and this side should be 6. Okay, so hopefully that makes sense. Again, our scale factor is greater than 1, so that means our figure is going to be larger, because 9 over 6, we're going to end up with a number greater than 1 if we divided that out. So hopefully you can kind of see the correlation here a little bit on going from a smaller figure to a bigger figure. Okay, so let's go to the next one, which is the same kind of problem. So we're going to create figure D with a scale factor of 1/4. So again, that is smaller than 1. 1/4 is smaller than 1. So that means that our figure D is actually going to be smaller than figure C as we go through that. So As we look at C, both sides are 8. So if we take 8 and multiply that by 1/4, okay, that is actually equal to 2. 8 times 1/4, because both sides are the same, so that's going to be equal to 2. Okay, so that means our new triangle that we're going to make is going to be 1, 2. So it's going to be 2 tall right there. And we're going to go 1, 2. So we're going to go 2 that way. Connect them with a straight line. Okay, so that is figure D. And again, our scale factor is 1/4. That is smaller than 1. So we're going from a larger to a smaller figure. Okay, so when you draw these in homework, be as accurate as you can, but make sure that you're always giving me side lengths in here so that I can tell that your numbers are accurate. Okay, so let's just make sure that we're always doing that. Okay, again, if you have homework on this, make sure you're asking questions for both these assignments, because you're going to take a quiz again on Wednesday. That's going to cover basically these 2 days of scale drawings and scale factors. Okay, so make sure that you're prepared for that. So make sure you do your homework before you go to do your quizzes on Wednesday. So again, I hope you guys have a great week. Please email me with any questions. If you need to set up a Zoom conference with me because you want questions answered in person, or I can show you on a whiteboard of such, please email me and let me know. We can certainly set up a time to do, and I can set up a Zoom conference. We could talk face to face and make sure that get your answers, your questions answered. So I'm willing to do whatever it takes for you guys to be able to figure this out. You're going to have to know this for pre-algebra next year. So let's make sure to do the best we can to figure this stuff out. So good luck with it, and I hope you have a great week. Again, only 2 weeks left of e-learning, so let's make sure that we're staying focused and getting this stuff done and doing the best we can to finish out this last 9 weeks. So, miss you all. Hope you have a great week. Bye.